Hi, good morning, everyone. Today I'm going to go ahead and continue with this Marshallian and Hicksian demand curve. So what we have done in the last class is a case of Cobb-Douglas function. We started with the direct utility function. We went ahead and found Marshallian demand. From Marshallian demand, we went ahead and found indirect utility function. We transformed the indirect utility function to find the expenditure function. And from this expenditure function, we went ahead and we found, using Shepard's lemma, the Hicksian demand function. This is the process that we followed to find the entire Marshallian and Hicksian demand. Now, today, let's go ahead and continue this and do this for the second scenario, which is the complementary goods. So I am going to take a basic perfect complementary good utility function. Let's say that my utility function is u is equal to min of x comma y. Now, whenever you get a utility function like this, which is a min function, it is always referred for complementary goods. What are complementary goods? The goods that are used together. Like, for example, left shoe, right shoe. For example, tea, sugar. For example, tea, milk. These are all complementary goods. They're supposed to be used together, pen and ink. Now, in case of complementary goods, in this min function that you are given, step 1 will always be to go ahead and find the kink. That's what the first step is. You find the kink of the complementary goods. The question is, how do we find this kink? In order to find the kink, whatever comes inside the min function has to be equated. And I'll tell you the reason why we do that. So for example, here, if I have x and y, I will equate x equal to y. And that will give me the kink line. Had my utility function been u is equal to min of ax comma by, then I would have equated ax equal to by, and this would have been my line of kink or kink line. This is how we solve it for complementary goods. Whatever comes inside the min function is supposed to be equated. Now, why is that the case? Well, that is because of the very property of the min function. Take this example. For example, I take x as 4 and y as 5. Supposedly, I take y as 5. Then the min of 4 and 5 will be 4. I take y anything greater than 4, but I keep x constant at 4, I will always get the answer as 4. So whenever I have x less than y, then the min of x comma y is going to be x always. So the utility will be equal to the value of x, because that is what the min of x and y is. Now, for example, you have x greater than y. Again, my utility function will be min of x comma y. But now, between x and y, minimum is y. So my utility will be equal to y. But if x and y are equal to each other, then the utility, which is minimum of x comma y, will simply be X or Y. We have to remember this. We have to see this pattern carefully. Now, what does this mean? This means, in very simple terms, if I take left shoe and right shoe, if I have X as the left shoe and Y as the right shoe, I can have 5 right shoes and 4 left shoes, but that will only give me 4 pair of shoes. 1 right shoe would be additional. I can have 4 left shoe and 10 right shoe. Still, I will only be able to make 1 pair. So, irrespective of how many Y's I have, as long as X is less than Y, that's the number of pair of shoes I will get. Just an example of complementary goods. Supposedly, it's the reverse. Y is 4, but X is 5. Then also I will make 4 pairs only. The 5th shoe would be of no use to me. But if X and Y are equal, then also I will have the same pairs, 4 pairs. So ideally, I am saying that if I need 4 pair of shoes, I can have 1, 2, 3, 4, 1, 2, 3, 4. Either you can give me 4 pair of both left and right. I'm taking left here, right here. This is my X, this is my Y. Or you can give me 5 of right, 6 of right, 7 of right. But keep left at 4. All of them will give me 4 pair. Or you can keep right at 4 and give me 5 of left, 6 of left, 7 of left. Then also it will make 4 pairs. So actually, if I jot down all these points together, I will get an L-shaped curve. It would be king at X equal to Y. That's the number of pairs I will be able to make. You keep on increasing X, holding Y constant at 4, I will have the same number of pairs. You keep on increasing Y, holding X at 4, I will again have 4 pairs. So this point, this point, this point, this, all of them give you the same level of utility. They give you the same level of shoes that you have, the same pair of shoes. Now, because of this, we can also kind of think of a kink line passing through X equal to Y. So I have a line, and this line is where X and Y are equal. So for example, if I take 1 here, and I take 1 here, I take 2 here, and I take 2 here. This is the line of kink that I have. This line of kink divides my space in 2 parts. This is part A of the space, this area, and this is part B of the space, this part. If I carefully notice, then this side of the space, if I take any point, supposedly I take a point like this, here. This part of the space has X which is more than Y. Y is 2, X is 3. So throughout the right hand side, I always have X greater than Y. You take any point in this green zone. Take a point here. X is 3, Y is 1. Take a point here. X is 4, Y is 2. Take a point here. X will be 4, Y will be 3. So throughout the green zone, and this is important, the line of kink divides the area in 2 parts. The right hand side of the zone is where X is greater than Y. That's the first part. So we go ahead and we just jot down this. Now the second part is where X is less than Y. Y is more than X. Take a point like this. X is 1 here. Y is 3 here. So all these points represent X less than Y. And we just formulated that whenever X is less than Y, the utility is always derived from X. So whenever X is less than Y, which means in this zone, My utility is always the line of x. So I draw a line through x by holding x constant. Similarly, when x is greater than y, my utility is always derived from y. So I draw a line through y. And when x and y are equal, then it's just that point where I am on the king. So this actually goes ahead and defines the same L shape, which says that in the zone where x is less than y, you have your utility defined by the line where x is consistent or x is constant. When x is greater than y, you have a line of u equal to y. And that is what we are doing geometrically. Here I am saying x is equal to 2. This is a line where x is equal to 2. This is a line where y is equal to 2. So I'm actually defining a line utility only by x, right? This is how we draw lines. When I say draw a line that x is equal to 4, what will you do? You will say, okay, x is held constant at 4. This is my line. And whenever x is less than y, I just have to focus on the line of x. Whenever x is greater than y, I have to focus on line of y. So this gives me this L-shaped curve. This is how we draw the shape of complementary goods. Now, one property of complementary goods is that whatever comes inside the min function is equated. You will always consume in that ratio. X will be equal to y. But I know that I cannot just keep consuming infinite. I cannot say that I'm consuming 100 units of x and 100 units of y, 500 units of x, 500 units of y. I am being constrained by my budget line. So although I have to consume equally, I have to consume x equal to y, but my budget line is px into x plus py into y equal to m. This is the constraint that I have. So if in my constraint, I put x instead of y, because the two are equal at equilibrium, I can say px into x plus py into x is equal to m. So I can take x common and I can get px plus py equal to m. From here, I can get x star is equal to m by px plus py. You know x is equal to y, so y star is also equal to m by px plus py. You should do enough practice of deriving the Marshallian demand curves so that if in exam you get a question related to these curves, at least this basic answer you should know. That comes with practice. You should know that it is m by px plus py when x is, when I have a function min xy. Now, had my function been min ax comma by, I would have just said ax is equal to by. So y would have been a by b into x. Instead of y, I would have substituted a by b into x. Everything would have been in terms of x. You would have found the value of x. So here you can now literally do it for anything. Your min function could have been min of 4x comma 7y. Equate 4x equal to 7y. Y is equal to 4 by 7x. Instead of y, put 4 by 7x. Get entire function in terms of x. Solve for the value of x. So you just have to remember what is the procedure that is followed in case of complementary goods. Now, once I have found x star and y star, these are my Marshallian demand function. The next thing will be to go ahead and find utility. So utility is basically min of x comma y. I have got a value of x. This is min of m upon px plus py, comma m upon px plus py. X and y are same, so the min is the same number. So you will get m upon px plus py. So your indirect utility function will be this. Indirect utility function. It will be a good idea to go ahead and see if the properties that we suggested yesterday still hold true for this indirect utility function, which means you have to go ahead and verify if it's increasing in income, decreasing in prices, and homogeneous of degree 0 in income and prices. So you just verify these properties. Here it's coming in the numerator. So when you differentiate, you will get 1 by px plus py, which is greater than 0. Here it is coming in the denominator. So when you differentiate, you will get minus 1 by px plus py whole square into m less than 0. Here when you multiply, instead of m, you write tm. Instead of px, you write tpx. Instead of py, you write tpy. You can take t common. So this is simply t to the power 0 into the initial function. So therefore it is of degree 0. So which means that the properties that we did yesterday for Cobb-Douglas function, that it is non-decreasing in income, non-increasing in prices, and homogeneous of degree 0 in income and prices, hold true even when we move away from Cobb-Douglas function and go towards the complementary goods, right? So now we have done step 2, where we have found IUF, indirect utility function. Let's find expenditure function from there. So my indirect utility is V is equal to M by Px plus Py. From here, my M will be V into Px plus Py. This is nothing but my expenditure function as a function of prices and utility. I'm holding utility constant at U bar, so Px plus Py. This becomes your expenditure function. Expenditure function is just rewriting the indirect utility function. I could have written V itself here. I'm just writing U bar because that's the technique that books use. They usually write U bar to represent a same level of utility, a constant level of utility. Had you written V here, it would have been fine. Nothing wrong with that. You're just representing it by utility. So it's fine. So this gives you the expenditure function. Now, once you have the expenditure function, the next part is to go ahead and find Shepard's lemma, using Shepard's lemma, the Hicksian demand function. So do that once. Just derive this using Shepard's lemma. Hicksian demand of good X will be del E by del Px, which will be U bar. Hicksian demand of good Y will be how expenditure changes with Py, which is again U bar. So this is my Hicksian demand. So we have been able to solve the entire question. We started with min function. We found out what is their Marshallian demand. We used those Marshallian demands to go ahead and find what will be indirect utility function. From indirect utility function, we found out what will be expenditure function. From expenditure function, what would be Hicksian demand. That finishes this complete part. Now, diagrammatically, you would have gone ahead and represented it like this. This is my budget line. If I look at my budget line, this is M by Px, M by Py. I want to go and attain the highest indifference curve possible. Is this the highest indifference curve? No. I can go above. Is this the highest indifference curve? Yes. Is this the highest indifference curve? No, this is not within my budget. So this is the highest indifference curve that you attain, and this is the point of equilibrium which happened at the kink. Again, proving that equilibrium happens when x is equal to y. This is very, very important from exam point of view. The entire min function and substitute good functions. Okay. Any doubt in this before I go to substitute goods? Anything you want to ask? Okay, we'll go to substitute goods then. In case of substitute goods, I am saying that I have goods which can be used in place of one another. So for example, tea, coffee, for example, ball pen, gel pen, etc. Now, the usual way of writing substitute goods is U is equal to AX plus BY. This is a general form. But I'll take first of all the case where simply I'm having XU is equal to X plus Y. I'll talk in detail about AX plus BY, maybe today or in the next class. In fact, a little complicated case than this also. But let's begin with this general case where I have U is equal to X plus Y. If I ask you, what is the MRS of this utility function? MRS in absolute terms, leave the negative sign, will be MUX by MUY, which is nothing but how utility changes when X changes upon how utility changes when Y changes. So how is utility changing when X is changing? Differentiate with respect to X, you'll get 1. Differentiate with respect to Y, you'll get 1. So the answer is simply 1. Now, if I have to plot these indifference curve, I can hold utility constant at 4 and I can get 4 is equal to X plus Y. This is clearly a line. So when X is 0, Y is 4, Y is 0, X is 4, X is 2, Y is 2. So if I have to draw this indifference curve, I will get 1, 2, 3, 4. This will be my indifference curve. This represents utility at 4. You can have different indifference curves. This represents utility of 3, this represents utility of 2, utility of 1, and so on. So these are my set of indifference curves, as we call it as the indifference map. Now, with substitute goods, we have various cases that we have to see. This case usually depends on what is the ratio of prices and MRS XY. The ratio of prices is nothing but the slope of budget line. This is nothing but the slope of indifference curve. We have to see whether the slope of budget line is less than the slope of indifference curve, greater than the slope of indifference curve, or equal to the slope of indifference curve. To do that, what we do is the following. So we begin by saying that the ratio of prices is Px by Py. MRS XY I will write as is. And I will take the first scenario when this is less than MRS XY. In my case, I found out that MRS XY is simply 1. This depends again, okay? Had my function been AX plus BY, then my MRS would have been A by B. Differentiate with respect to X upon differentiate with respect to Y. In this case, when I differentiated, I got 1 by 1. So the answer is 1. So my first case is when Px by Py is less than MRS. Here, I can rewrite this as Px by Py less than 1 because my MRS is just 1 in this case. This gives me Px less than Py. And this tells me that whenever price of good X is less than price of good Y, and because they're substitute goods, you can either use X or Y. You can either use a ball pen or a gel pen. You can either drink coffee or tea. So because they're substitute goods, whichever good is cheaper should be bought because you can buy more of it. If a gel pen costs you 10 rupees and a ball pen costs you 5 rupees, you'll go for a ball pen because you can buy more of the ball pens. So here in this case, because my Px is coming less than Py, I get the situation that I should buy only good X because X is cheaper. So because I am buying only good X, if I go ahead and write my budget line, Px into X plus Py into Y is equal to M, instead of Y, I can write 0 because I'm buying only good X. X and Y are substitutes and X is cheaper. So plus Px into X is equal to M, or Px into X is equal to M, X is equal to M by Px. So I get my first scenario here that when Px by Py is less than MRS XY, then you should consume only good X, which means X star will be M by Px and Y star will be 0. Let's see what this means diagrammatically. See, please understand that Px by Py is less than MRS XY. In this case, indifference curve and budget line are both lines. Indifference curve is not a curve. I don't have any tangency point. They're both lines, but with different slopes. So one will be flatter, one would be steeper depending on their slopes. So I'll give you the simplest way to check when is a line steeper and when is a line flatter. Supposedly, I take Px by Py as half and MRXY as 1. Clearly, half is less than 1. Now notice what I'm going to do. Half means perpendicular is 1 and base is 2. So perpendicular is 1 and base is 2. 1, 2. This is your budget line slope. Here, because it is 1, perpendicular is also 1 and base is also 1. So you have your indifference curve aligned like this. So clearly, this is a flatter line. Whichever line has a lower slope is always flatter. Supposedly, we take the other way around. Let's say that Px by Py is 4 and MRS XY is 1. Then 4 means 4 by 1 and 1 means 1 by 1. So in this case, I am saying, how do I draw this budget line? It is 1, 2, 3, 4. Perpendicular is 4. It's always perpendicular by base. Base is 1. So this is my budget line. Give me a second. Okay. And in the other case, I am saying MRS XY is 1. So perpendicular is 1 and base is also 1. So you get it like this. So clearly this becomes steeper and this becomes flatter. Whichever line has a lower slope will be flatter. Whichever line has a higher slope will be steeper. Now, let's go to this case first. So I'm still doing the case that Px by Py is less than MRS XY, which means my budget line is going to be flatter. So Px by Py less than MRS XY. This means that my budget line would be flatter. So I draw this as the budget line. Okay, this is my budget line. My indifference curve was steeper than this. So maybe this is my indifference curve. This is my indifference curve. Now I ask a very simple question. Which is the highest indifference curve that you can reach while you stay within your budget, while you spend money within your income level? Is this the indifference curve? The answer is, I can go on a higher indifference curve. This spends some part of my income. It's on my budget line, but I can go higher and still be on my budget line. I can go higher. Even here, I'm spending equal to my income. I can keep going higher until I reach this point. This is also on budget line, but I am on the highest indifference curve possible. Can I go higher? No, because then I would be above my budget line. No point of the indifference curve will touch the budget line. So when Px is less than MRS XY, I reached a point of equilibrium, which is here. This is the highest indifference curve I have reached. And at this point, I see that I am consuming only good X and no good Y. Well, exactly what we analyzed mathematically. That when Pxy was less than MRS XY, I was getting price of good X less than price of good Y, and I was consuming only good X. And in that case, my consumption of good X was M by Px. Exactly what we interpreted. So we have got the same thing diagrammatically also. Now let's reverse the case. Case 2. Here I am saying Px by Py is greater than MRS XY. Now think what should happen. So if Px by Py is greater than MRS XY, I should be saying that Px by Py is greater than 1 because my MRS XY is 1. So which means my Px is greater than Py, which means good Y is cheaper. So I should consume only good Y. So in this case, if I go back to my budget line, which is Px into X plus Py into Y is equal to M, instead of X, I will write 0 plus Py into Y is equal to M, and I will get Y star is equal to M by Py. And I will get X star is equal to 0. You should try and analyze the same thing diagrammatically also. Why am I emphasizing diagrammatically? Because when we do complicated questions, it is only the diagrams that help us to understand where will I reach my equilibrium. So diagrammatically, I can go ahead and say that my budget line is now steeper because it has a higher slope. This is flatter in difference curve. So I draw my budget line first. And then I start plotting my indifference curves. So this is my indifference curve. Is this the highest indifference curve? No. I can go higher. I can go higher. I can go higher, higher, till I reach this point. This is the highest indifference curve, which is within my budget. And this point, I'm consuming only good Y. So this is where Px by Py is greater than MRSXY. Budget line is steeper than the indifference curve, and you consume only good Y. Now let's take case 3. Case 3 is what happens when Px by Py is equal to MRSXY. If they have the same slope, then they are the same line. So what I am doing is, I am saying that this is my budget line. My indifference curve has the same, it's a parallel line. It's the same slope as the budget line, which is the highest indifference curve I can reach. I can go here. I can go here. This is the highest I see possible when it coincides with the budget line. And when I am on the budget line, my X can be anything between 0 to its maximum value. I can consume a point here where I'm only consuming X. I can consume a point here, a point here, a point here, or a point here where I'm not consuming X at all, where X is 0. And once you decide on X, then you can put that value of X in the budget line equal to M and get a value of Y. So Y will simply be M minus Px into X by Py. If you decide, for example, that you don't want to consume X, then Y will be M minus Px into 0 by Py, which is simply M by Py. So it will be this point. If you want to consume X exactly half of your income, so your Y will be M minus Px M by 2 by Py. So different combinations. If you want to consume entirely X, then your Y will be M minus Px M by Px by Py, which will be 0, which will be this point. So X can vary to any amount here. You can consume any combination of X and Y because they have equal price. If they have equal price, I can distribute my income half-half on both of them. If they have equal price, I can just still consume one of them. I can consume the other of them. I can make any combination possible. So we have 3 cases in totality. Case 1. When Px by Py is less than MRS XY, in which case you consume only good X. So your X star becomes M by Px and Y star becomes 0. Case 2, where Px by Py is greater than MRS XY, your X star is 0 and Y star is M by Py. Case 3, where Px by Py is equal to MRS XY, X star is anything between 0 to M by Px, and Y star is the remaining amount, M minus Px into X by. This is your Marshallian demand. Once you have found the Marshallian demand, you have to go ahead and find the indirect utility function. What is indirect utility function in this case? Your utility was X plus Y. So when you have Px by Py less than MRS XY, so you were having X equal to M by Px, Y equal to 0. So X plus Y will be M by Px. When you had Px by Py greater than MRS XY, in that case, your X was 0, your Y was M by Py. So your utility, which is sum of these two, will be simply M by Py. And then there is case 3, when Px by Py is equal to MRS XY. In this case, you can consume any amount of X, any amount of Y. So your X was anything between 0 to M by Px, and Y was M minus Px into X star upon Py. You can add these two and get the indirect utility. Now, please see that my indirect utility function is either M by Px or M by Py, or this, which will also come out to be either M by Px or M by Py or something in between. So I'll take two extremes. When X is 0, it will come M by Py. When X is M by Px, it will come M by Px, right? So it will be between these two values only. If I have to give one line, one formula to represent these two things, then what can I really write about them? That my utility, indirect utility, is either M by Px. This happened when Px was less than Py, or it is M by Py. This happened when Px was greater than Py. So whenever Px is less than Py, I get Px in the denominator. Whenever Px is greater than Py, I get Py in the denominator. Can I go ahead and say that my indirect utility function is M upon what I get in the denominator will depend on whichever is minimum, whether Px is less than Py or Py is less than Px. So m upon min of px comma py. This indirect utility function takes care of all possible scenarios. When px is less than py, then min of px and py is px. And I was getting this as the utility function, m by px. When py is less than px, then min of px, py was coming as py. And I was getting this as my utility function. And in the third case, it can be either of this. You can put an equal to sign here or an equal to sign here. That's fine. So your indirect utility function precisely can be written as m by min of px py. This is something that has come a lot of times in different entrance exams. You would not be given a function like this. You would directly be given something like this. And you would be asked, which of the following words have this kind of utility function, m upon min of px py? Now from here, you can go ahead and find the expenditure function. Just rewrite this thing. So you will have indirect utility is equal to m upon min of px comma py. So from here you will get m is equal to min of px comma py into u bar. So you will get expenditure function as a function of prices and utility as min of px comma py into u bar. This becomes your expenditure function. Please think about this once. Is there any doubt that you want to clarify? This is very, very important. Because from here, I'm just going to build upon this. This is going to act as a base for me. So you have to understand how I derive this indirect utility function for substitute codes. And then I have just rewritten it to find the expenditure function. But this in the background had various cases, px by py less than MRS, px by py greater than MRS, etc. You have to understand all these cases very well. Now, I've got my expenditure function. There is just one last step left. I have to use Shepard's lemma and find out Hicksian demand function. So I go ahead and I use the Shepard's lemma and I find Hicksian demand function. What is Hicksian demand function? Demand in terms of utility and prices. What is Marshallian demand function? Demand in terms of income and prices. So for Shepard's lemma, I say case 1, if px is less than py, then my expenditure function will be min of px and py will be px into u bar. So, my x will be how expenditure changes when px changes, which will be u bar. And my y will be how expenditure changes when py changes, which will be 0. So when px is less than py, Hicksian demand function for x is u bar, for y it is 0. Take the other case now. If px is greater than py, then min of px and py will be py. So your expenditure function will be py into u bar. In this case, again, your xh will be how expenditure changes when px changes, which will be 0. And your YH will be how expenditure changes when PY changes, which will be U bar. So when PX is greater than PY, then min of PX and PY is PY. Then your expenditure function is PY into U bar. And your Hicksian demand is 0 and U bar respectively. Take the third case. If PX is equal to PY, then your expenditure function can be written as anything. You can write it as PX, you can write it as PY. So you will simply have XH equal to U bar, YH equal to 0, or XH equal to 0, YH is equal to U bar, in case you write it as PY into U bar, or any combination in between also. So you can have anything in between because the two are equal. So this is actually the scenario of substitute goods. This is very, very important. You won't be asked directly to derive substitute goods. Substitute goods would be within some part. It would be given in some different format from which you'll have to solve that utility function to get to the level of substitute goods, and then from there all this continues. So you have to be very thorough with the parts where we did the basic min function, substitute good function, we'll do max function, quasi-linear, so that whenever I pick up a complicated question and I simplify it to the form of substitute goods or complementary goods, from there you can pick it up and you can do all these steps. I will not be doing this continuation of the steps from there. Okay. Now let's do a third kind of utility function, and they actually act very, very similar to substitute goods. They're very similar, and they're known as my max functions. So the max functions have a utility function that looks like max of x or y. What is one property of these max functions? These functions represent goods which give you positive utility. However, the two goods cannot be consumed together. For example, milk and wine. Milk gives positive utility, wine gives positive utility, but you cannot go ahead and consume milk and wine together. You cannot consume X and Y together. So even when the prices of X and Y are equal, either you will spend only on X or only on Y. You will not have a combination that you can consume. Unlike substitute goods, where when tea and coffee have the same price, you can spend half of your income on tea and half on coffee. You cannot do that with max goods. Max goods have this property that you don't consume them together. Even when the prices are the same, either you go with only X or you go with only Y. So how do we write these max functions? Now, to solve this, I'm again going to take three cases. I can have X less than Y. When X is less than Y, max of X and Y will be Y. So my utility will be simply Y. I can have X greater than Y. So my utility will be max of XY, which is simply X. I can have X equal to Y, in which case I just get my point of king. Right? So how do I go ahead and draw the indifference curve for this? Now again, this is my line of king. The line of kink is always derived by equating what comes inside the max function. So here I have equated x equal to y. This is the zone where x is greater than y. This is the zone where x is less than y. When x is greater than y, then you have u equal to y line. So you have a line of y here. And when x is less than y, you have u equal to y. So when x is less than y, you have a line at y. And when x is greater than y, you have a line at x. And this is the point of king. So the utility function for a max code is inverse L-shaped. And this makes sense. Take this example. For example, I have 4 here. I have 4 here. And this is a point which is 4, 4. So the max of 4, 4 will simply be 4. But suppose I take a point here. This is x is 4, y is 0, but the max is still 4. So it gives me the same utility that I'm getting at the point of king. Take a point here. Suppose this is x is 4, y is 1. So max of 4 and 1 is still 4. So this point also gives you the same utility as this point and this point. This point is y is 4, x is 0. Again, I have to find max of 0 and 4, which is 4. So all these points give you the same level of utility. And because they give you the same level of utility, they have to be on the same indifference curve. That is why you get this as your indifference curve. Now, here, unlike the min goods, the max goods act very similar to the substitute goods. So I take case 1. And this case is when Px is less than Py. If price of good is less than price of good y, it can be like maybe my x is milk, maybe my y is wine. So if Px is less than Py, then I'm going to go ahead and consume all of milk. Because it's simple. Both of them are giving me positive utility. I cannot consume them together. So I will consume the one which is cheaper. How do I show this? Supposedly, because Px is less than Py, I get from here a budget line, which is, let's say, Px by Py less than 1. So let's say my Px is 2, my Py is 3, and this is less than 1. If I have to jot down the budget line for this, this is 1, 2, 1, 2, 3. This is my budget line, 2 by 3. You should always take some numbers to draw the budget line. That way, it is always simpler to draw it. So I understood that Px is less than Py, which means Px by Py is less than 1. So I can simply take Px as 2, Py is 3. You could have taken anything. Px as 3, Py as 4, Px as 4, Py as 5. You will get this as the budget line. Now, I have a line of king passing through x equal to y. All my indifference curves are L-shaped along this line of king. So this is my indifference curve. This is also my indifference curve. This indifference curve, it touches the budget line, which means it consumes at this point all of your income because it has a point on the budget line. But is this the highest indifference curve that I can reach? No. I can go to an indifference curve which has point at 3, 3. This point is also on the budget line, but I am on a higher indifference curve. This was giving me a utility of 1. This gave me a utility of 2. This gave me a utility of 3. So I'm on a higher indifference curve. And to reach this indifference curve, where am I? I am on a point where I consume only good X and 0 units of good Y. So that becomes my equilibrium. So when Px is less than 1, Px by Py is less than 1, or good X is cheaper than good Y, I get my equilibrium where I consume only good X and 0 units of good Y. That becomes my equilibrium. Now take the reverse way. When Px is greater than Py, then good Y is cheaper. So you consume only good Y. But while I am doing this, don't we realize that the max goods are acting very similar to the substitute goods? When price of good X is less than good Y, you consume only good X. When Px is greater than Py, you consume only good Y. So aren't we acting very similar to substitute goods? With only one exception, that when Px is equal to Py, even when the prices are equal, either you spend all your income on X or all your income on Y, but not a combination of two. Otherwise, they're acting as substitute goods. Whichever is cheaper, buy that, you will get more of that. So here, I can go ahead from here and solve it exactly like substitute goods. My Marshallian demand function will be when Px is less than Py, X star is M by Px, Y star is 0. When Px is greater than Py, X star is 0, Y star is M by Py. You just put here X star equal to 0 in budget line, you will get this as Y star. And when Px is equal to Py, this will be Px, then either you get this M by Px comma 0 or 0 comma M by Py. Nothing in between. That's your equilibrium. So, because they act very similar to the substitute goods, the indirect utility function for the max goods is same as substitute goods, M upon min of Px comma Py. When Px is less than Py, then you are getting your utility as M by Px. When Py is less than Px, you're getting your utility as M by Py. Why? Because once you have got this X and Y, your utility was what? Max of X and Y. So it was max of X star and Y star. X star is M by Px, Y star is 0. So its max is simply M by Px. Here, max of 0 comma M by Py is simply M by Py. So your utility that you're getting is simply M by Px or M by Py. It is M by Px when Px is less than Py. It is M by Py when Py is less than Px. And from there, you get your indirect utility function as this, m upon min of px comma py. So you don't have to really solve for max functions. Max functions act very similar to substitute goods. Although they're not substitute of each other. You're not saying that milk is a substitute of wine. Still, the good property about them is that they cannot be consumed together, just like substitute goods, with a slight difference that they don't substitute each other. So you will only consume the good which is cheaper. And therefore, you will get a utility function, indirect utility function, expenditure function, everything very similar to the substitute goods. Is there any doubt in this? Anything you want to understand? They're very important functions. Okay. Now, let's go to the last type then. These are called quasi-linear utility function. Now, what is a quasi-linear? First of all, what is the word quasi? What does that quasi mean? So quasi word actually means partial, half, near to linear. So quasi-linear utility function has two parts to it. One part is where we have the linear aspect, and the other part is where we have the non-linear aspect. So one of the goods that we have is linear, and the other goods that we have is non-linear. Now let's see how do we write these utility functions. Just give me a second, please. Okay. So this is my utility function. U is equal to root x plus y. X here is coming non-linearly and y is coming linear. Let's see how to go ahead and solve this kind of utility function. So what I'm going to do is step 1, I will again go ahead and solve using Lagrange. So I form a Lagrange and I say that my utility that I have to maximize is root x plus y, and my constraint is my usual budget constraint, so plus lambda m minus px into x, py into y. Remember, there is no compulsion. You can do this also with the method of substitution. You can do this also with the method of equating MRS to px by py and putting that in the budget line. I follow Lagrange because I can generalize it for all my problems. I will follow Lagrange throughout. So now you differentiate this with respect to x. You will get 1 by 2 root x plus lambda minus px is equal to 0. So from here, your first equation will be 1 by 2 root x is equal to lambda px. You differentiate this with respect to y and you will get 1 plus lambda minus py is equal to 0, which means you will get 1 is equal to lambda py. This is equation 1, equation 2. You're going to go ahead and divide 1 by 2. So you will get 1 by 2 root x by 1 is equal to lambda px by lambda py. So your lambdas would get cancelled and you will get 1 by 2 root x is equal to px by py, or you will get x star is equal to py by px into 2 whole square. This will be your x star. Now, can you go ahead and identify something which happened differently in this case when you found out x star? One thing that didn't happen till now whenever we were finding x star, but this is the first time when I see very different value of my x star. What is that one thing that is missing from this x star? Any hint, anything that you can think of that is missing from this x star? Well, this x star, unlike all the Hicksian demand functions that you had found out, has missing m. Your x does not, in this case, depend on your income. It is not affected by the income level. So because in this case, x is not affected by income, what are we really saying? We are saying that the optima x does not depend on what your income is. You will always buy it. So x actually acts like a necessity good. It's like salt. It's like the basic toothpaste. It's like toothbrush. You will buy these goods irrespective of your income. You will buy salt irrespective of your income. That's the basic thing required for survival. So x does not depend on the income level. Now, if instead of this, let's go ahead and find out the value of y. So what is your y? Y is nothing but m. So how do you write your budget line? Your budget line is px into x plus py into y is equal to m. In this case, I am getting my x as py by 2px whole square into px plus py into y equal to m. I'm just replacing x from here, from this value. I'm just replacing it here. So I will get px into py square by 4px square plus py into y equal to m. And just find y from here. So you will get y is equal to m minus py squared by 4px 1 by 2. So you will get y equal to m minus py by 4px by 2. This will be your value of y. Y is not a necessity good. Y depends on the level of income. See here, y depends on m. Y is not a necessity good, but it is x which is a necessity good. X does not depend on income. X will be consumed irrespective of the level of the income. But that does not hold for y. Now, from here, let's just solve this y a bit more. So I will get y star. If I just take denominator common, I will get 4px py. Here I will get 4m into px minus py square. Now here is the thing. See, px and py, they are positive numbers. So px into py is positive, into 4 it is positive. So the denominator is always positive. But let's just for a second think about this numerator that we have here. The numerator that we have can be negative, 0 or positive. What if this numerator 4mpx minus py square is either 0, or less than 0? What if this numerator is either 0 or less than 0? Then in that case, your y cannot be negative. You cannot consume negative quantity, but it will come out to be negative or 0. So in that case, your y would simply be 0. So if your numerator is negative or 0, y star will be 0, because you cannot consume negative quantity. If y star is 0, then you're spending your entire income only on x. In that case, if you look at your budget line, and instead of y, you go ahead and you put 0, you will get your x as m by px. So your quasi-linear function has two answers. Answer 1 exists when the numerator of this y is positive. So when 4m px minus py square is strictly positive, then in that case you will consume x star as py upon 2px whole square. This is what your x star came, right? Py upon 2px whole square, and you will consume y star as 4mpx minus py square upon 4px py. But if your numerator is less than or equal to 0, then your x star will be m by px and your y star will simply be 0, because the numerator is negative. This question came in one of the exams. This was asked. Suppose 4mpx minus py square is negative with the utility function root x plus y, which is the equilibrium condition. What is the value of x star, y star? This came in one of the entrance exams. So you have to solve this and understand that if the numerator is coming negative, you cannot consume negative quantities of y. It simply means that you're not consuming y. And if you are not consuming y, you are spending your entire income on good x. So x becomes m by px. And this was also one of the options, that x star is py by 2px square. But in this case, x is not this. X is this. You're spending your entire income on x. Now, once you have found the Marshallian demand, then it's simple. You can do it. Indirect utility function will be root x plus y. So in this case, it will be root of x will be root of this, which will be py by 2px, and y will be 4mpx plus, minus py square upon 4px py. This will be your indirect utility function. And in the other case, in this case, your indirect utility function will simply be root of m by px plus 0, which will be root of m by x. Root x plus y was your function, right? So this is your indirect utility function in the two cases. You can solve for income from both the sides and get your expenditure function. So from here, you can find your expenditure function. And here your expenditure function will be u bar into root px whole square. This will be your value of income, right? So u bar square into px. Here also you can find your expenditure function. Equate this to u bar. So it will be u bar minus py by 2px plus py square by 4px py into 4px py by 4px. This will be your value of income. So this will be your indirect utility function. And then you can use your Shepherd's lemma and find del E by del px and del E by del py. Here also you can find it. Del E by del px will be u bar square. Del E by del py will be 0. And here it is going to be, you can solve for it and you'll get an answer here and get an answer here. This is simple differentiation. But what is important for quasi-linear utility function is this approach, this part. Most of the students just get this as the answer. They solve for x and y, but they do not take this into consideration that the numerator of y can be negative also, in which case you will not consume y at all and y will become 0. And when y will be 0, then x will not be this, but more than this. You will spend your entire income on x. So x will be m by px and not py by 2px whole square. This holds as long as you consume y also. Otherwise, this is your Marshallian demand. And accordingly, you will get two cases to find indirect utility function and expenditure function and Hicksian demands. So you have to be very careful while analyzing this question. Any doubt that you have? You should be practicing this on the very same day. If you extend this and wait for the next day, you may not be able to understand this thing. Okay, before we end the class, I'll give you a question. First you try and then I will tell you how to solve it. This came in Delhi School of Economics 2017 paper. And quite recent. And the question said the following. You were given a utility function which was min of xy into z. So see, they have tricked the question. They have gone ahead and introduced three goods, x, y, and z. And it said that the expenditure, or simply they said that the prices were P1, P2, and P3. And the budget line was simple, P1x plus P2y plus P3z equal to m. And it said, find equilibrium level of, this is the question. And four options were given to you. So you're given a utility function. The utility function has a min function, but only in some part. See here, it's only in some part that this utility function has a min function, not completely. So you will use the properties of what min function we did, but there is a little more to that. And then this is your usual budget line that is given to you, although in 3 dimensions. P1x plus P2y plus P3z is equal to m. And they asked you to find the equilibrium level of x. Now, whenever you would be given a function which has more than 2 goods, you will always solve it in 2-step budget. Now, what is this 2-step budget? So what you will do is the following. You will say, suppose, and carefully look what I'm doing. I introduce a new utility function that only represents min of xy. This part of the utility function, I say that, min of xy will be either x, either y, either x or y, depending on whatever is minimum. But I say that this part of my utility function, I represent it with some new alphabet. It can be any alphabet. So then your utility function becomes this phi into z. Okay. This is your new utility function. This utility function in turn has this utility function combined in it. And now I say that suppose the income spent on good x and y is M1. I am introducing 2-step budget. So my total income was M. I know x and y are complementary goods. So x and y will be equally consumed. But totally on x and y, I am spending M1. And my income really is M. So which means on Z, I am spending my remaining income M minus M1. But let's just focus for a while on this M. If M1 is what I am spending on good X and Y, I can write a smaller budget saying that the income, the expenditure I do on X plus the expenditure I do on Y, that is equal to M1. I'm spending M1 on X and Y together. Now, from the exercise that we did, I'm not going to do that again, but I know that if X and Y have a utility function which is min of xy, and if this is my budget line that I have, then I know from what we did in the beginning of the class that x1 star will be m by px plus py, where m is my income spent on good x and y, so it will be m1, and y star will be m1 upon px plus py. X and y will be consumed in the same proportion. So instead of y, you can replace x here, and then you will get x is equal to m1 upon px plus py and y equal to m1 upon px plus py. This is the amount that I'm going to spend on x and y. Is this clear? I am forming a 2-step budget. My income was m. I am spending out of that entire m1 on good x and y. But since these are, min function, they are consumed in equal amount. So I get the same amount for x and y. Now, if you ask me what will be this utility function in that case, this will be min of x comma y, which will be min of m1 upon px plus py, comma m1 upon px plus py, which will simply be m1 upon px plus py. This is what my utility function will come out to be. was your budget line that was given to you? The budget line was P1 into X plus P2 into Y plus P3 into Z is equal to M. How much money are you spending on X and Y together? M1. So this part is M1. So M1 plus P3 into Z is M. So what is your M1 really? M1 is M minus P3 into Z. So instead of this M1 everywhere, I can rewrite this as M minus P3 into Z. I can rewrite this as M minus P3 into Z. I can rewrite this also as M minus P3 into Z. Now I have a value of V, which is in terms of M and Z. I will go back to my original utility function and replace this V with that value. So my utility function was V into Z. I found out a value of V, which is M minus P3 into Z upon P1 plus P2 into Z. The entire utility function is only in terms of Z. You can maximize this utility with respect to Z. So when you maximize this utility function with respect to Z, how utility changes when Z changes, equate it to 0, you will get M minus, this will become Z square. So its differentiation will be 2Z into P3 equal to 0. So from here you will get Z star is equal to M by 2 P3. You've got your Z star. What was X star? X star was this. M minus P3Z upon Px plus Py. So X star will be M minus P3 into Z upon Px plus Py. This will be M minus P3. Instead of Z, I will write M by 2 P3 upon Px plus Py. So your X would be M upon 2 Px plus Py. This will be your X star. This is called two-step budgeting. So notice that you are not going to get a straightforward question on min function. But you have to use the properties of the min function. You should know that if it is a min function, I have to apply kink to it. I have to consume equal amount of X and Y. That's the property that helped me to solve this. I should remember how to find the Marshallian demands of X and Y. This kind of question has been repeated 2 to 3 times in the past year in Delhi School of Economics and in ISI. I've done one type. I will do many more questions of DSE in the next class. But for that, you have to revise this, solve this question at least thrice so that you understand this question very well. What is a two-step budgeting? How do we first allocate some amount of income on X and Y, find X and Y from there, put that back in the utility function, make the entire utility function in terms of Z, and then solve for Z. So that's the two-step budgeting that we follow. So tomorrow, I'm going to introduce to you 2 very difficult, extreme kinked functions. One is min of X plus 2Y, comma 2X plus Y. The other is max of X plus 2Y, comma 2X plus Y. You will only be able to solve this if you revise what is min, what is max function, and this two-step budgeting that we did. in this question. Okay, thank you.